Hi, I'm Geoff Filippi. Welcome to Rocky Mountain Angular. We're talking tonight about TypeScript, and later we're going to talk about Angular observables, but kick it off with TypeScript. So if you don't know me, I'm an application architect, and I work at a company called OilDex. We do cloud services for oil and gas companies, so I've been there about 2 years now almost. I used to be at Time Warner Cable, so you might have known me from there. I was there 12 years. I worked on streaming media, so voice over IP for about 6 years, and we had 5 million customers when I left that group. Also worked on video and streaming video for the last 4 years I was there. We built a video streaming website, kind of similar to Netflix or Hulu, something like that. We used Backbone.js when I was there, and we also built a video streaming set-top box web app, and that's in a way similar to what a Roku box or one of these other boxes would look like. But at OilDex, I've been rewriting 10-year-old web apps, basically from the ground up, so they're greenfield rewrites. We started in July doing Angular2 and TypeScript, so we've been doing that with success for a couple of months now. But tonight we're going to talk about TypeScript, and we're going to start off talking about the background, some background information. And then we're going to cover TypeScript and its syntax. And then I'm going to show you some tools and tips that you can use TypeScript with. One thing, if you've seen TypeScript talks before, usually they have a lot of content about ECMAScript 2016 or ES6 or whatever. We're going to talk briefly about that, but this is really focused more on the stuff that's not included in ES6 and ECMAScript 2016. So just some background, in case you're not aware, I mean, JavaScript already does have types. It has the primitive types, booleans, nulls, things like that. And it also has the object type. So these are things that were built into the language in ES5. But JavaScript does use a dynamic type system. So what that means is you can declare a variable, and then you can actually change its type at runtime. And that's totally valid JavaScript in ES5 and ES 2016. So like in this case, I declare a variable foo as 42. That's obviously a number. I can declare or just change its value to a bar, and now it's a string, or I could make it true, and now it's a boolean. And you obviously, if you wouldn't re-declare it, but if you can change the type as you go, and that's good because it's easy and it's simple and it it doesn't trip you up. But it's also bad in some ways, and we'll talk a little bit about that. But the way that people have done typing in JavaScript up until now, other than the native types, is you end up with a thing called duck typing. And what we mean by that is the type of the value is determined by some kind of runtime test that you write yourself. And this is done in other languages too, but it's not unique to JavaScript. But by example here, we're going to talk about a function duck. And that function duck has the ability to quack, right? So also you have a function cat that only knows how to meow, right? So knowing that, you can create these objects, and then at runtime you'll check what type of object do I have, so you can actually do a type of and find out if it's a function, and if it is, then you can try, so what I'm doing here is I'm trying to see if this thing I have, does it have a quack function? If it does, then it's a duck, or it's close enough, for what I need to do. So that's kind of the idea of duck typing. You find out and you test specifically the things you need the object to have, and if it has them, you just go right ahead as if everything's the type you want it to be. And you don't really worry about what else it has that you don't need. So in this case, obviously a cat doesn't have a quack, so it's not a duck. So that's some of the background, and I think that's basically what you need to know to be effective with TypeScript. So we'll get into some of the syntax of TypeScript here. So if you haven't used TypeScript or looked into it, it's actually a type superset of JavaScript. What that means is it has all the features of ES5. It also has all the features and syntax of ES6 and 7 or 2016 and so forth. But it also has its own features, so additional features on top of that. And it does compile to plain JavaScript. So after your compilation step is done, you're just dealing with JavaScript again. And it could be whatever target you want to send it to. So you can compile TypeScript to ES6, or you can compile it to ES5. But because, this is what you'll see in a lot of TypeScript talks, because it's a superset, it has all these same features, which, things like constant, let, fat arrow, promises, async and await, and decorators and things like that. But, those are all things that you're also going to be able to use in TypeScript, but they happen not to be specifically TypeScript features. But, TypeScript does understand JavaScript types, and that's, really important because it's not just that it runs JavaScript, but it also knows what to expect. So when you do those declarations that we were looking at earlier, TypeScript knows what to expect, and when it sees you changing types, it can warn you about that. So it knows about booleans, nulls, defines, and those things. But it also adds some types. So some of the types that you'll see that are unique to TypeScript are the tuple or an enum. You can also use any when you really don't want to specify the type. So if you're in TypeScript and you're like, well, I still want to use that dynamic, behavior, you can just, declare it as an any. And you can also use that in your interfaces, and we'll talk about that. And you can also, of course, return the void type. So if your function doesn't have a return type, you can, specify that as well. So some of the additional features of TypeScript in addition to the new types. So it does have static types, including static typing on variables, static typing on parameters. So in your functions, you can tell your functions what type they should expect. You can also type what the return values are going to be. And it also has this feature of implicit types, which means that it can see what your code's doing and make an assumption. And the assumption is, we'll get into how that works. But once it makes the assumption, it knows what type you have. And that saves you a lot of the boilerplate. So if you've ever coded in Java, like I have, for years, some people really had a bad taste in their mouth over Java types because it's like every time you want to declare a variable, you have to say what type it is. When you have a function, you have to say what type it is. When you have a return value, you really don't have to do that in TypeScript, although you certainly can. TypeScript also has a feature called generics, and we'll get into that. So this is an explicit type, and this is kind of the good way to do it. This is a correct explicit type. So I'm using ES 2016 let to declare a variable, but I'm also saying in TypeScript that this is a string. So the way you declare the type is with a colon and then the type itself. So, and then my var has the value hello, which happens to be a literal string. So this is valid TypeScript, and this will pass. But this is what TypeScript is supposed to help you out with, right? Obviously, you can do this yourself, but when you have lots of declarations, sometimes you get confused, or maybe one of your colleagues gets confused. So here I'm declaring my var as a string, but then I'm assigning it to a number. So this is not valid in TypeScript, and this is what kind of the key feature of TypeScript, which is to warn you when you did something wrong, something you shouldn't have done. And so if I run this, I'll get the type number is not assignable to string from TypeScript. So that'll help you. You can see how that's such a simple example, but in more complicated examples, it'll help you by maybe you have an employee or a customer, and it'll say, hey, customer is not a valid employee, employee is not a valid customer or whatever. So it'll help you, make sure you're passing the right things around. So, but that was explicit, and I had to actually type it out, and that's fine. It's not a lot of typing, but why should I have to do that, especially with things like strings and numbers? So here I can declare a variable myvar and just assign it to a string. And because of the implicit features of TypeScript, TypeScript is able to imply the type of that assignment. And so now after this, TypeScript is actually aware of the fact that myvar is a string. And if you reassign it to a string, that's fine. It knows that that's valid. But here in this example, if you reassign myvar to a number, it's going to warn you. And in fact, it's an error. But so this is kind of the nice thing that people from Java would appreciate, and people in Scala expect it, and other languages. Your compiler should be smart enough to know what type you're assigning something to, so that you really don't have to spell it out. But of course, if you want to, that's valid TypeScript as well. So the next feature I want to talk about with TypeScript is interfaces. So interfaces is a great way to, especially in things like APIs or things that call APIs, or if you're writing a library, or really any code that you want to share with others, you can go ahead and declare what the types are that make this object a valid implementation of that interface. And this is something like if you're from C# or whatever, or Java, you probably do this all the time. But here in this thing called labeled value, what I'm saying is, in order to honor the interface contract labeled value, it has to have a label, and that label has to be a string. And so, I can create, basically down here, I can have the function print label that says, well, I expect a labeled object, because otherwise what am I going to print, right? And then it can actually go about printing out the label. And so the way to use a library like that is to say, I'm going to create an object, and I'm going to make sure it has a label, and then I'm going to call print label on it. And so now print label is able to detect the fact that this is actually, this has got the thing that it's supposed to have. And if it doesn't, then the compiler can warn you. So that can definitely have a good benefit when you're getting data from a server, and it's like, well, I don't remember what the shape of the data that's coming back is. Well, if you've defined an interface for it, you don't have to remember, because the tools will show you. And we'll get into tooling and stuff later in the presentation here. So, those are the main key features of TypeScript, and some of them you've probably seen in other languages if you're familiar with those. But I'm going to talk a little bit about how to actually use TypeScript. So, your web framework that you're using, if you're using Angular, of course, it's going to be built in. But if you want to use it in Node, or if you want to use it in another framework, you can just install TypeScript globally, on your np install -g, and that'll get TypeScript up and running on your terminal. And I've already done that, so I'm not going to do that here, but I will create a terminal. Okay. So some of the tooling that TypeScript provides, and it's one of the main power features of TypeScript, is in your editor, in whatever editor you choose. I'm going to show tonight VSCode, or Visual Studio Code. You have the feature called Intellisense. So when you're typing, it'll help you autocomplete. It'll help you look up the method signatures and things like that. You can also peek and see, like, what is the code that defines these things. And it also helps you, like, if you want to refactor. So it knows about types, and it knows, okay, well, if I change the name here, where else do I have to change it? It also helps you with reference lookup. So when you use something, where, what's its actual definition and things like that. So we're going to look at that. So let me go through Intellisense. So, here's an Angular app that I generated a while ago. But let me see. I'll pull up something here. So some of the features that you might want to use, like, I can go to the definition of title. Where was that defined? And I can also float above it and see, okay, well, title's a property, and what type is it, and things like that. So let me see if I can get something with better, let me get a more interesting module here. So this one's got a little bit more going on, so we can see things like, where, import app component, where am I using it, and also where was it defined. So, it's loading the code. So all of this comes from the features like static analysis, because I can, in TypeScript, it knows how to read all the files that I have, and it knows how they're related to each other. So I can go and open and locate where that code was defined. And what else do I want to show? Like refactoring, like if I wanted to change a component, and things like that, you're able to, change all occurrences and things like that. And it can go across files and it knows how to understand like imports and things like that, like in the ES module syntax. Also finding all references. So this is the peek feature, right? So I can go and see other places where I've used it, and I can, navigate through those. So, these are things that just make coding, easier and easier to find your way around other people's code in particular. And as your app grows, it'll help you keep track of where you are, things like that. So those are some of the main features I think that because of this static analysis, because TypeScript compiler understands the code better than would otherwise, it's able to help you find definitions and look things up. And also, like if you're going to call a function, or let me do that here. All right. So let me do the bootstrap. That's usually a good one. Yeah, let me just do here. So things like this, I can do like browser module. Is that big enough? So, and it's going to highlight errors for me, things like that. And then I can see inside of here. Let's see.
Maybe a little bigger, actually.
Yeah, okay. How's that? Any good? So yeah, things like that. And let me see if I can get a good example going here. Okay, well, I'm going to skip ahead. So yeah, I was like, what went wrong here? Okay, that's better. Yeah, I think something broke. But anyway, okay. So yeah, that's the idea essentially, though. So how does some of this work? So one of the things you're going to want to use when you're doing TypeScript is, and most of your, if you're using a framework like Angular, this is already included. But essentially, it's going to allow you to load things from your libraries, like say you're using not a good moment, or trying to think of one that everybody will have used, like translate. It's going to be able to understand the types the way they're defined in the library, even if the library was written in JavaScript. So not just for TypeScript libraries, but for JavaScript libraries too. And it's so when you're using those libraries, that it's going to help you autocomplete, and it's going to help you know how to call the functions and know what types they expect and everything like that. And so there's a pretty big ecosystem of type definitions, and that's what the typings project is for in the tool itself. So it helps you load those types. So depending on if you're using Angular 2, it's already built in. So when you load a module, it's going to load the types for you. But if you're not, then you should certainly consider it for things like Node. One of the things that's definitely helpful is, like, if you're using Node, you want to load the Node APIs. And Node is obviously written in JavaScript, not TypeScript, but it knows all the types. It knows everything about Node. So once you have that, you'll be able to call like file system dot, and it'll be able to autocomplete the file system API for you, and you'll be able to do things like that. So definitely check that out if you're using Node. But if you're using Angular 2, it's built in. So if you're sitting there thinking like, okay, well, I definitely want to use TypeScript now, but how do I get started? I've already got an app. It's not in TypeScript or whatever. I'd say, like, here's some recommendations I would give you. Like, the first thing I would do is, if I'm going to start a new app, especially Angular 2, I would definitely start that app in TypeScript. So that's just the cleanest way. Get everything set up and just go ahead and start doing it. And for me, if you're going to start a new app in Angular 2, use the CLI, because the CLI will have all the tooling. Everything's already built out. You don't have to like figure out how to integrate with the compiler and stuff like that. But if you're using another framework or using Node, then definitely it's still a good time to think about starting out in TypeScript, because it's brand new and you don't have to worry about converting code. But if you have legacy code like we all do, there's some things you can still do, right? So I would definitely recommend that whatever your editor is, like you don't have to have VS Code to have these features, because TypeScript actually builds up. It's a compiler service, so it actually works with most modern editors. I use Vim. It works with Vim. It works with Sublime. It works with Eclipse. It works with IntelliJ, and probably everything else you're using. So go ahead and figure out how to install the to your IDE, and you'll actually even get help with TypeScript or with JavaScript projects. So check that out. And that's like a simple thing you can do. Even like if your team's like, no, you're not using TypeScript or whatever, you can do it in your own editor. So you can also bring in type definitions for any of your dependencies. I would definitely take a look at that, even if you're not using TypeScript in your project. So like if you're using something like jQuery in your project, you can bring in the type definitions for jQuery. And then the compiler and the IDE will start helping you out with, okay, well, here's a jQuery command, function you're calling. What's its signature look like? And it'll also help you, like if you called it the wrong way, like if you passed a number, you're supposed to pass a string. It'll help you with that. So that's something you can do anytime, right away, really. You can also run TypeScript compiler on JavaScript. So the way I would do that is like you can put into your, we'll talk about, you can integrate TypeScript into your build process. And even if TypeScript errors out, it'll still emit JavaScript. So you don't have to successfully compile. You'll still get the best JavaScript it can put out. So that'll start to help you pick off problems. And you can also use your TypeScript compiler. You can exclude files that you know are not going to pass the compiler if you just don't want to deal with the errors. But I think it's a good thing because you can start looking at the errors and start thinking about, did I really mean to change types here? Because one of the things that if you're interested in the runtime, or even if you're not, when you change types against the browser has a JavaScript engine in it. And when you change types on that engine, it actually has to recompile the thing that you change types on. So it actually slows down the performance of your app when you're changing types. So it's kind of convenient and nice that JavaScript doesn't care what type, but actually your browser cares, and the thing that runs your code actually cares a lot. So even if you think it's fun to change types, like you might want to think twice if in a performance situation, especially. You can also, one thing I recommend taking a look at is, even if your project isn't using TypeScript, you can start using TypeScript in your test system. So one of the things that provides you, like right out of the box, like if you look at depending on how your unit tests are written, and I've seen this over the years, you'll find unit tests which actually all they do is check types. So those can go away because your compiler will test that for you. So take a look at that. But it's also good because if your tests are correct, they're going to be more dependable. So if you've ever had the problem where your tests fail every now and then, depending on the input, it may not be, but it could have to do with types. So one of the things that can help out is just getting your tests into TypeScript. So like your Mocha or Jasmine tests. But you can also use type annotations. Like if you run into a problem and you're like, I'm not sure what's going on here, and you're starting your regular debugging process, you can start annotating your code as you go until you run down the problem. And then even if the problem wasn't type related, well, now you've already made those assertions, and so you don't really have to. You'll never have to go back over that again, at least. So I think you can migrate individual files to TypeScript as you go. And sometimes when you're debugging, it does turn out to be a type-related issue. But also, along the same lines, if you find a bug and you find the fix, and especially if you find it's type-related, then you can certainly take that opportunity to add types to that single file, so that error never returns. But also, if you write libraries for your team, or your team produces its internal libraries, you should definitely consider writing a type definition for that library, because now every time you use that library, it's going to tell you what the definition of the types are, and also help you autocomplete and the functions and everything like that. So that way you don't have to flip back to the documentation or go read the source code. Although with TypeScript, it's really easy to look up the source code. And if you do find anywhere in your code doing that duck typing pattern, you should definitely consider switching it out to TypeScript, because then you don't have to do that. And the problem with the duck typing pattern, it has runtime consequences because you're actually checking things at runtime. But if you can check it ahead of time, then you don't even need to bother with those checks at runtime. So think about that as well. So with that, if anybody has any questions, I'd be happy to talk about it.
In the description, like in the meetup description, it says TypeScript 2.0 is in the release candidate stage. Do they actually know what a release candidate is compared to Angular?
Well, actually, I think it's finally released as well, because I sent the blurb in before. Let's see. So I think they actually finalized it. When did they do it? Very recently, but since that blurb was written. Go to GitHub. Oh, there. Start. Yeah. So now releases. Yeah. So it's out of RC. So I don't know if they know better about RCs than Angular, but one thing that comes up is kind of a side note, but in Angular 1 they actually had like 7 release candidates too. So I don't know if it's just their style or whatever, but it's good. Matt.
You said TypeScript is a compiler and it handles a lot of the ES 2015 stuff. How does it play with like Babel?
So the question was like, how does TypeScript as a compiler play with Babel? And I actually don't know of anybody using them together, because for me, TypeScript does what Babel does, but it does other stuff too. So
That mean you can set the different stages for plugins like Babel, you can set stage.
yeah, they have, there's basically a TypeScript config file, and in the config, I think I have it here. In the TypeScript config file, you can put in certain options. So like you can say, I want to use decorators. Oh, sorry, I highlighted the wrong line. So like, yeah, I want to use decorators. That's experimental. You can turn that on, things like that. So I wouldn't recommend using them together. I would pick one you like best. But I think they both do share some implementations. So I think it's JS Core or whatever. So there's some things that they do share. So.
Been reading a lot of TypeScript source code, and it might be legacy now, but one thing I've been seeing is like 3 slashes and then a link to a file at the top for typing.
Mm-hmm.
And then another thing is like the old way of declaring types, for example, in other languages, is with the caret syntax. And can you still do that?
Yeah, so the question was like, what about this this kind of older way of declaring? And actually, I read through the release notes for 2, and I didn't see that was pulled out. So I think that it's still valid. I think what I would say about it is it's more like discouraged, I guess, because tools like typings take care of that for you. Like, so you don't need to like go in your individual TypeScript files and have like the kind of here's where my type is. You don't really need to do that anymore. So because of tools like typings. So if you have that in TypeScript code, take a look at typings, because you may not need to do that anymore. Like we don't have it in any of our new TypeScript code. So was that?
Yeah, and then the other piece was type declaration with caret syntax.
Oh yeah. Yeah, I haven't seen people do that for a while. I don't know. We don't do that. TypeScript type definitions with caret syntax. David.
Yeah, I was curious, to get the most out of TypeScript, do you recommend using Visual Studio or use all those tools like Intellisense? And you were talking about the beginning, or can you do that with other editors?
Yeah. So the question was like, to get the most out of TypeScript, should I use VSCode? Not necessarily. I would use whatever editor I already like, unless you might find yourself in the situation where like, I really hate my editor. I wish I had a better one. Well, then for sure check out VSCode or Atom, or ask around. But all of the ones I looked at already support TypeScript. So and it's usually through a plugin. So if you've got an editor you already like, go ahead and try TypeScript out in that first, because all these features probably work in your editor. So, and I use Vim, which is like the clunkiest editor arguably in the world, but it totally works fine in Vim and Emacs and whatever. So if you got an editor that you like, it's going to work probably. So, Matt?
So because it's a compiler and we're now being declarative on what they actually are, is there any reason to still do like triple equals and operators, or does the compiler still handle that?
Oh.
Kind of like CoffeeScript does.
Yeah. So yeah, the question was like, since we're compiling now, should we, consider, and we actually have type, checking as well. Does it still make sense to use triple equals? And I would say it does still make sense to use triple equals because triple equals is, if you're not clear on that, it prevents type coercion, and double equals still allows type coercion. So the one thing that the one thing that's different though, but it also it informs the answer is because we're using ES modules, which I didn't cover tonight, but you can find slides from when I did cover it up on GitHub. ES modules enforces use strict, and so you're going to get that semantics when you have triple equals, and also it also is going to warn you about double equals, like a lot of linters do. So I would still tend to use, we still use triple equals. And so I think that's, I don't know if we'll ever get away from using triple equals, because I think there's still those rare cases where you really mean to use double equals and you want it. So I don't, I know CoffeeScript kind of paved over that a little bit. I was never really a big CoffeeScript guy, but.
Well, with CoffeeScript, if you did like double equals,
Yeah.
the compiler would change it
Change it to triple equals. Yeah, so if you didn't hear that, yeah, in CoffeeScript it would change double equals to triple equals, which I think is okay, but that doesn't happen. That doesn't do that in TypeScript. I think the only problem with that is occasionally you do want double equals. Although I think the best way to do that, the better pattern is to do explicit type coercion. So do it yourself, and and then you don't have to let it be implicit. So. But if you didn't follow that, don't worry too much about it, but we can talk later.
I saw a source map setting in your TS config, so it does source maps.
Absolutely. Yeah, for sure. So the question was about source maps. So when you're actually writing TypeScript, you're not shipping TypeScript to the browser. So you're compiling it down to JavaScript, and that's also handled in your TS config or TypeScript config. How do I want it to come out? And what kind of modules, but here where we're talking about target, what we're saying is what kind of code should this emit? And for this setup, it's ES5, which means it'll run in almost all browsers, except for like really old IE browsers. And there's a couple of others that you probably won't have to target. So, but the thing is, like, now I'm reading code that's different than the code I wrote, which is annoying sometimes. Although I think Babel and TypeScript and what's the other one, Tresor, they all kind of do fairly readable JavaScript, although you can argue about that because they're not really, their goal is not to write readable types JavaScript, their goal is to write fast JavaScript. So sometimes that's at the expense of readability. But what we do instead is we create this thing called a source map, which the compiler for TypeScript handles for you. Babel also do those. And what that does is when even though you're running ES5 in your browser like Chrome knows how to read a source map, and it'll actually, when the error occurs at runtime, it'll map it back to your original source code if you post your source code or your maps. And so that's a really good feature, especially before you get into production, but I think even after, because unless you have your editor, unless you have your debugger on or your Chrome DevTools on, it's not going to download the maps. So nobody else is getting the maps unless they're trying to debug your website, and hopefully that's a good thing, like one of your techs or whatever, or your devs. But if you don't want those in production, you can also leave them out in production. But then you're kind of stuck debugging in production. You're just debugging emitted code, but it's fully supported.
Also, how hard is it to use like third-party libraries that don't have typings for them?
Mm-hmm.
Say you really press for time and don't want to create typings. How hard is that to work with?
Yeah. So the question was like, okay, what if I want to use a library that doesn't have typings? Then how hard is that going to be? You can actually, it's actually not going to be that hard. You in your config, you can exclude files, but you can also do like you can do like a top level any and stuff like that. So you can tell there's a couple different ways you can tell TypeScript to ignore a piece of code that doesn't have types. And also, if it's .js and it's not in your source, so you have like these different ways to tell where your code lives. So like if it's in your vendors or whatever, depending on how your project's set up, you don't have to run TypeScript at all on your the compiler at all on your vendors folder. So absolutely that shouldn't stop you. But a lot of the libraries you do want to use do have typings. So and they're not terribly hard to write if you want to write them, but use your judgment there. Let me go to Matt and then I'll come back. Yeah, Matt.
So, like right now I use Babel and Webpack together. Does this also kind of handle Webpack being able to do like tree shaking and things like that, or do you still use this with Webpack?
For sure in Angular2, we're going to, especially if you use the CLI, you'll be using Webpack and TypeScript together. So, and it does, I know more about Angular2 than any other way of doing it, but so with Angular2, it will be able to do the tree shaking through Webpack as well. So, and that's through, it has less to do with TypeScript and it's more to do with ES modules, because in ES modules we can do static analysis, although Babel and TypeScript support ES modules. But what it means is like, because of the way the imports are defined, I can go through and actually, before the codes run, know what code I'm using and what code I'm not using because of what I imported or didn't import. So that's going to work, I would think, equivalently in anything that uses Webpack. So, yeah.
So we're on 1.5.
Okay.
How bad would it be to go to TypeScript? Is that a good idea? Should we wait
Yeah.
till we switch to 2 to go to TypeScript?
Yeah. That question comes up a lot for me anyway. So, and we had to think about that. So the question was, if we're on 1.5, should we move to TypeScript? And I would say it might not, my opinion from doing it is not really worth the time. Although you might want to look at doing it in like your tests or something like that. Or you might just want to at least turn it on your editor and like, look at the errors that you do get. But for me, like we have Angular 1.5 apps with components. We're actually looking more at rewriting them in Angular 2. We'd rather spend the time there. So, and then of course they'll be in TypeScript for us. So you have to use your judgment on that, but I think any rewrite, you kind of have to decide where do you want to end up. And doing rewrites at different stages is kind of the most expensive way to do it, but it also might be necessary for you, like because you might not have like, for instance, like you may not have enough dev time to get it done in one go. So it might be something to think about, like, do I want to, approach it in the stages, but obviously it will be more expensive overall. Another way to look at it is to take your Angular 1 app and use the ng upgrade features, which I haven't really done much of. But then you can take each component and turn it into an Angular 2 app or Angular 2 component, and then those components can all be in TypeScript. So that might be a more effective way to get to TypeScript in Angular 2. But I guess that all assumes you're going to Angular 2 anyway, which, I don't know, I kind of feel like most people, given the time, would go to Angular 2, but that may not be true for you. So, but that's kind of what I would recommend is think more about going to Angular 2 than just upgrading for TypeScript. Because TypeScript, I think in Angular 1.5 doesn't buy you as much. So I don't know if other people have done it. So any other questions?
Yeah, are interfaces more of a global concept, or are they scoped? Let's say if you declare one inside of a class, can you only use that interface?
Well, yeah, the way it works is, I didn't show all the different ways of using it, but the way you would traditionally use it is you would have, you define an interface just like any class, and then on those classes that you want to adhere to that interface, you would just say that it implements the interface. And so you can use the interface throughout your application, anywhere that you want to have something that implements the interface. Or if you're really only using it in one place, you can have your interface defined above your class. So I wouldn't say that, it kind of depends on what you want out of it, but a typical pattern would be to say, I have a class called vehicle, and I have an interface declared above it or in a different file called vehicle. And then you can just say, well, I just want to make sure my vehicle adheres to the interface vehicle or implements vehicle. But if you have places where you're just like, well, I have different vehicles and I want to have, this gets into like object-oriented design or whatever, but if I have different vehicles like truck, car, whatever, I might want to declare interface vehicle and then have all of those classes use it. And so it kind of depends on your domain, like what you're trying to model. Anything else? Yeah, one more.
So if you're targeting ES5, so one of my big pain points right now with Babel are there's like this massive polyfill library I have to throw in a phone and use
Yeah.
any cool ES6 features.
Yeah, and you have the
Does
same
that all
here.
get compiled in, or do you need polyfills?
Yeah, so TypeScript itself doesn't need polyfills unless you want to compile TypeScript in your browser, which is cool if you're like experimenting, but you definitely don't want to do that in production. But it obviously, I mean, I don't know if it's obvious, it does rely on ES6 type of polyfills. So like ES core, or and I can show you really briefly the ones that it does depend on.
So you don't need to specify a polyfill for like fetch to work in Safari.
Yeah, let me show you. There's actually a package. Okay, here we go. So yeah, here are the ones that we, core.js is the main one. And if you're using Babel or other things, so you're probably using that too. So this is the kind of thing that you're still going to carry around with you until all the browsers support all the things. But also, if you're using Node, you're going to need the same kind. You either have to restrict yourself to using features that Node 6 or whatever you're using supports, or you need to throw a polyfill in there as well. So it kind of is up to you, but it's kind of a necessary thing, and it has a lot more to do with JavaScript than anything to do with TypeScript.
Is it just coincidental that you're using Angular RC5, or is there a reason for that?
Yeah, this is just this is what I generated the last time I had a talk, basically. So yeah, so now at my office we're using RC4, and we looked at 5, 6, whatever, but now that Angular2's landed, we're gonna migrate. We're gonna do a small migration to RC6, and then we're gonna do a small migration to final. So that's if you're in the same boat as me, I would recommend, if you've been thinking about it and holding off, I think now's a good time to migrate, because we've got the final and we're in Webpack and CLI is updated. So CLI is not final, but it's pretty, what we've seen is pretty good. So